to Sri Sathya Loka Seva Gurukulam online classes. So we've been learning differentiation. In today's class, we are going to see the geometrical representation of differentiation. So let's consider a curve. Let this represent the function y is equal to f of x. We are considering any point P, x comma y on the curve. So let's suppose that we are considering this point P, x comma y. Now we are talking about a small increment to the x value, meaning we are raising the x value by delta x. So let's suppose this is the x here at this point. We are trying to plot another point with a higher x value. So I'm moving down onto the right on the x-axis and landing at a point here. So if you see this point Q is going to represent a value, its x coordinate will be definitely more than the x coordinate of P, and its y coordinate even on the vertical axis, the y value is going to be less than y plus delta y. So we have incremented x and y with small quantities and consider another point on the neighborhood very close to P, that is Q. So our Q is going to be x plus delta x comma y plus delta y. So what is differentiation? In the previous video, we've seen in length what is differentiation. So basically, we are trying to look in for limit delta x tending to 0, delta y by delta x. This is our dy by dx. So now, how do I find delta y? The value of delta y and delta x. So what is delta x first? Delta x is going to be this complete distance of n from O is going to be my x plus delta x, considering the position of Q. And this position, the distance OM is going to be x, considering the position of P. That's x comma y. So what is my delta x? My delta x is going to be the difference of ON minus OM. So x plus delta x minus x, this distance is my delta x. The distance between P and Q on the horizontal axis. Now similarly, let me understand my delta y. My delta y is going to be the difference of this entire distance minus this distance. That is the vertical distance between P and Q on the vertical axis. So my delta y is going to be equal to Qn minus this distance, that is Pm. So this is my delta x, this is my delta y. So let me now understand what I want. I want this, that is my derivative. So let's understand that graphically. So limit delta x tending to 0, delta y, that is Qn minus Pm divided by On minus Om. Now what does this mean? Delta x tending to 0. Meaning my delta x is 0. What does that mean? It means that I am not going to a neighboring point, but I stay at the point itself, right? So now let me explain it to you in a geometrical interpretation. Just look at it. Now I was talking about the distance of PQ. I have taken a point P and then moved on till Q. To represent that on my curve, I'm going to join it with a line. That's the chord. When I extend my chord, I get a secant. I extend it. Look at this. This is the secant that gets extended. Here it is getting extended. And it makes an angle alpha with the x-axis. Now, when I tend my delta x to 0, I mean to say that my q and p are going to coincide. So, what do? I only talk about this p. Now, my q and p are going to coincide. So, this q is slowly moving and becomes p alone. So, my delta x tending to 0 is going to be p and q on the same place. So what happens to this chord? The chord does not remain to be a chord, it turns into a tangent because this distance is going to be 0. When I move that, it becomes a tangent touching the curve at just single point and not 2 points. So the chord converts into a tangent. So now, when I talk about this distance, so my limit delta x tending to 0, the difference, that is delta y by delta x, is given by limit delta x tending to 0. The distance here, that is y plus delta y minus y divided by x plus delta x minus x. So when we consider this as x1 comma y1 and this as x2 comma y2, we are basically talking about y2 minus y1 by x2 minus x1. That's nothing but the slope of the tangent at that particular point P. So it's so clear that the geometrical representation of your derivative is going to be the slope of the tangent at that particular point. So in short, I was talking about y plus delta y minus y by x plus delta x minus x. That's nothing but this distance by this distance. When you consider this triangle, opposite by adjacent is the tangent of the angle. So that's tan alpha is equal to y plus delta y minus y by x plus delta x minus x. This is equal to my del y by del x. dy by dx is going to be equal to limit x tending to delta x tending to 0, delta y by delta x, that is equal to tan alpha initially, and that is going limit delta x tending to 0, tan alpha. My delta x tending to 0, tan alpha will be equal to, when it tends to 0, it becomes a tangent. So this secant turns into be the tangent. So this moves and it makes theta with the x-axis. So this can be converted into tan theta. So this is my dy by dx. So when my delta x tends to 0, my tan alpha becomes tan theta. That's nothing but the angle that the tangent makes with the x-axis. That's called as the slope of the tangent at that particular point. So this is my geometrical interpretation of my derivative. So dy by dx represents the gradient of the tangent at that particular point. So let's move on. Let's look into this corollary. If a tangent to a curve at a point P is parallel to x-axis, then it says that theta is equal to 0. Now let's understand. So let's go back to this. Let me draw the curve again. So I have a curve. When I draw a tangent at this point, the tangent becomes parallel to x-axis. So we know that dy by dx is tan theta. Now what is theta? That the angle that the tangent makes with the x-axis. Now what angle will this tangent make with the x-axis? If you extend this, it's always going to be parallel to the x-axis. So it means that our theta is 0. So our dy by dx is going to be tan 0. What is the value of tan 0? You've learned in trigonometry, the value of tan 0 is going to be 0. Hence, if the tangent to the curve at P is parallel to x-axis, then dy by dx will be equal to 0. So whenever you differentiate any particular function and arrive at the value that its derivative is 0, then it means that the tangent at that point is going to be parallel to the x-axis. Now, the next corollary, what does it say? If a tangent to the curve is perpendicular to the x-axis, let's understand this. So let me have a curve like this. I draw a tangent to this curve at this point. It's a freehand diagram, so it might be a little deviated. So the tangent at this point is going to be perpendicular to the x-axis. So what's the angle that it will make? It will make 90 degrees with the x-axis. This is our theta now. So our dy by dx is equal to tan theta, that is equal to tan of 90, which is equal to infinity. So, if a tangent to the curve at P is perpendicular to x-axis, then its slope or the derivative is going to lead you to infinity. So the tangent to the curve represented by y is equal to f of x at a particular point P is parallel to y-axis if it leads you to infinity. So these are very important corollaries. Please do make a note of it. Then we'll move on to the next question. So now, we've seen in our previous video how to find the derivative of a function. That's basically your dy by dx using the first principle. So what did we do? We found dy by dx by using this formula that said dy by dx is equal to limit delta x tends to 0, f of x plus delta x minus f of x by delta x. Right? Now similarly, you can apply these formulas and try to find the derivative of the following functions. So in general, you can try to find the derivative of y is equal to x power n. This is called as a power function. It's an algebraic function with it's a general form of an algebraic function with n as its power. So use the first principle, use this formula to derive general formula for this. Because every time, as I told you in the previous video, if we need to use the first principle and get the derivative, it's going to be very big and complicated. Higher the power, let's suppose you have y is equal to x plus 10, the whole power 10. Then using the first principle is going to be really complicated because you need to know the binomial expansion of a function with raised to power 10. So it becomes very, very, very difficult. And at times it's going to be impossible. So we'll have to derive a general formula to make it easy for us to differentiate every time. So take this as an assignment. Try to prove y is equal to x power n using the first principle, this formula, to find its derivative. For now, I'll give you the formula. If f of x is equal to x power n, or your y is equal to x power n, the derivative dy by dx is equal to, when you differentiate this, it is otherwise represented as f dash of x is equal to n x power n minus 1. So this is the general formula. Please do make a note of it. With this formula, we are going to differentiate these functions that we have one by one. So let's take the first function, x. So f of x is equal to x. So our dy by dx is equal to f dash of x is equal to, I know the general formula that says if y is equal to, f of x is equal to x power n, our dy by dx is n x to the power n minus 1. So what do we do here? Basically, bring the power down. So the power is n here. Now here, what's the power of this variable? It is 1. 1 is a silent power of any variable. So here, since the power is not exclusively given, it should have a variable 1. It should have a power of 1. So the first step is to bring the power down. So what do? I have this 1. I first put that multiplied by the same function with one number less on the power. So when the power is 1, I just subtract 1 from it. So that is nothing but 1 into x power 0. You all know that anything to the raised to the power 0 is 1 itself. So this is 1 into 1 and that is equal to 1. So whenever we differentiate x, we get 1. This is a very important result. This will be using in all the questions that are yet to come. So please always remember that when x is differentiated, you always get 1. When x is differentiated with respect to itself, you get 1. Let's do the next one. So we know y is equal to x power n. dy by dx is going to be n x power n minus 1. So now let's differentiate. Y is equal to x square. So when I differentiate when I differentiate y with respect to x, I get dy by dx. And I'm going to differentiate the right hand side with respect to x. What do? It's a power function. I'm going to bring the power down first. So 2 into x raised to the power 1 less than the power. So this is nothing but 2x power 1. That's nothing but 2x. Let's do the next one, x cube. When my y is x cube, when I differentiate with respect to x, I get dy by dx is equal to 3 into, I need to reduce 1 from the power. So that's 3 into x squared. That's 3x squared. So easy, isn't it? I hope you all understand. Let's move on. So now, let's read this question. It says, find the derivative of each of the following functions. There's only one function. So we are going to find the derivative of this using delta or ab initio or first principle method. So let me tell you that all three methods are the same and it refers to the method that we've seen so far. That is limit delta x tending to 0, delta y by delta x is our dy by dx, and it's given by f of x plus delta x minus f of x by delta x with limit delta x tends to 0. So this formula is called as the first principle or ab initio or delta method. Now what's that ab initio? Ab initios are results that are obtained by observation and real-time application with no assumptions in place. So these functions are tested with the facts given. So that is called as ab initio method. So all these refer to the same method. So let's quickly do once and see how complicated it is and why we are in need of a formula. So our function here is f of x is equal to x square plus 5x. So in case in the examination any of these methods are asked, then you need to apply only that particular method. So now let me find f of x plus delta x. That is nothing but x plus delta x the whole square plus 5 into x plus delta s. So let me simplify this and keep it for my easy application. A square plus b square plus 2ab is what I am applying here. And I am opening up the brackets by multiplying 5 to the binomial. So 5 delta x. This is what I get. Now let me substitute it in this formula. So I have limit delta x tends to 0. F of x plus delta x is here, x square plus delta x the whole square plus 2x delta x plus 5x plus 5 delta x minus, I have my f of x that is here. So minus x square minus 5x divided by delta x. So what happens? My x square and x square goes off, 5x minus 5x. So here I have limit delta x tending to 0, delta x the whole square plus 2x delta x plus 5 delta x by delta x. So I can see that delta x is common across on the numerator. Let's take it out and factorize. So delta x taken out, the first term becomes delta x plus 2x plus 5 divided by delta x. So this gets cancelled, and when I apply the limits delta x tends to 0, this becomes 0 and I get 2x plus 5. So my dy by dx is 2x plus 5. So here I had to apply this principle, expand it, simplify it, make it ready to apply the limits, and then I had to apply the limits and get the results. So this is your delta ab initio or first principle method. Let's move on to the next question. So here it says find y dash when y is equal to 12x plus 12. Now here the method is not specified. So we are not going to use the first principle because we know that there are so many steps involved in it. So after using the first principle, we have few facts ready with us where we are going to use that and differentiate this particular function. So what do we know? When y is equal to x bar n, your dy by dx is equal to nx bar n minus 1. We are going to use this to differentiate. So when I differentiate y, what do I get? I get dy by dx. That is otherwise called as y dash. So I can even represent my dy by dx or my first derivative as y dash. So when they ask you for y dash, please do not get confused. That's nothing but dy by dx. So when I apply this, I have an x there. So this can be rewritten as 12x power 1 plus 12. I've already told you also in the same video that when I differentiate x, I'm going to get 1, but I'll still show you how it is. So 12 is the coefficient, keep it as it is. All numerical coefficients along with the variables in a variable term will be kept as it is when you differentiate. X power 1. So what do? We bring the power down and then subtract 1 from the power. Plus, I have a 12 here. This is a constant term. What happens to a constant term when I differentiate it? That's the next result that I'm going to give you now. Please make a note of it. The first result is this. When I differentiate a constant, I always get a 0. Why? What is the meaning of a derivative? It's the rate of change of a variable with respect to another variable. So when you alter a variable, what impact it has on the other variable is called as differentiation. So when you alter a variable, do you ever think there is a change on a constant? It's not accompanied by a variable. So there's definitely not going to be any change, right? A constant remains the same in any situation. So what will be the change to it when you make changes on another variable? There's not going to be any change, or the change is going to be 0. So whenever you differentiate a constant, it becomes 0. A standalone, a constant term on differentiation gives you a 0. So when your y is a constant, you can represent a constant by a, b, c, anything. So here I'm representing it by a. So whenever a function is a constant, its derivative is going to lead you to 0. So when I differentiate this, I have 12 into 1 is 12, x power 0, anything power 0 is 1, plus 0 is 0. Plus 0 is going to be 12. So my derivative dy by dx is 12. When I differentiate 12x plus 12, I get 12. I hope you understand. Let's move on to the next question. Find the derivatives of each of the following functions. Now let's observe how to do this. So here my f of x is this. So when I differentiate f of x, I represent it as f dash of x. My dy by dx given as y is represented as f of x, then my dy by dx is represented by f dash of x. This will be equal to, how do I differentiate this? So I have the result here. When y is x power n, my dy by dx is n x power n minus 1, and when my y is a constant, my dy by dx is 0. If you see here, it's sum of functions. So I have 1 here, 1 here, 1 here, 1 here. Or all terms put together. It's an algebraic function. So each and every term will be differentiated. So when my y is given as combination of functions, sum or difference of functions, when I differentiate my y, I have to differentiate every function on the right hand side. So my f dash of x is going to be equal to, so what's the coefficient? The numerical coefficient is going to be 1 by 8. Keep it as it is. Apply this formula to it. So my power is 8. So I multiply by 8. X power, I reduce 1 from the power. Similarly, I move on to the next term. I have 1 by 6 as the coefficient of the variable in that term. I keep it as it is. Then this x power 6, when I differentiate, it will be 6 x power 6 minus 1, that is x power 5, plus the numerical coefficient is 1 by 4. X power 4 on differentiation gives me 4x cube. The power becomes the coefficient when it becomes the derivative, and there is 1 reduced to the power. And this is a constant term. When I differentiate a constant term, it gets nullified, or it gives me a 0 on differentiation. So minus 2 becomes 0. So let me simplify and give it. So every function on differentiation gives me a function as a answer. So this is called as its derivative. So 8 gets cancelled. It is 8 power 7 minus x power 5 plus x cube. So this is my f dash of x. So when I observe, I can see that all my algebraic functions on differentiation gives rise to another algebraic function. So when I differentiate an algebraic function, I end up in an algebraic function. So I hope you understand this. Let's move on to the next question. So again, let's put the facts that we have, the formulas that we have. So y is equal to x power n. My dy by dx is going to be n x power n minus 1. And if my y is a constant, my dy by dx is going to be 0. So let me differentiate this. So differentiating f of x with respect to x is going to be, when I differentiate f of x, I get f dash of x is equal to, on the right hand side I have 3 terms. Each and every term I'm going to differentiate. So this is the first term. The numerical coefficient, it's going to remain as it is. And x power 2 by 3. So 2 by 3 will be brought down as a coefficient. Into x power, you reduce 1 from the power. Minus, similarly, I'm going to bring that power as a coefficient. X power minus 4 by 5 minus 1. Plus, this is 3 by x square. So how do I differentiate it? It's easy if I keep it as a variable of the form x power n. So let me first rewrite this. We'll rewrite this as 3x power minus 2. I'm sure you all will know the rules of exponents. The exponents on the numerator, when you bring it onto the denominator, the denominator, when you have an exponent, you bring it to the numerator, you change the sign of the power. So 3 by x squared becomes 3x power minus 2. On differentiation, this is a numerical coefficient, it will remain like that. I bring the power as a coefficient and then reduce 1 from the power. So let me simplify it. So here, this becomes 4 by 15. X power 2 by 3 minus 1 is minus 1 by 3. This minus and here minus becomes plus 4 by 5. X power minus 9 by 5 minus 6 x power minus 3. So always remember, whenever you have negative powers, when you write the answer, it's always good to express it in terms of positive powers. So we can write this as 4 by 15. X power minus 1 by 3 can be written as x power 1 by 3 on the denominator, making the power positive. So it's 4 by 15 x power 1 by 3 plus 4 by 5 x power 9 by 5 minus 6 by x cube. It's always good to express answers with positive powers. Hope you understand. We'll move on. So next is f of x is equal to root x by minus 1 by root x. So we know that if y is equal to x bar n, our dy by dx is going to be n x bar n minus 1. So whenever it is of this form, it's easy for me to differentiate. So when I have surds given to me, I would like to express it in exponential form for me to deal with it in an easier way. So how do I rewrite this? I can rewrite this as f of x is equal to root of x is nothing but x power half minus, this is 1 by x power half. And again, I'm going to rewrite it in this form because that's the best way for me to express when I have to differentiate. So this is x power half minus x power minus half. So the answers should have positive powers, but when I have a question, I need to express it of this form to make it easy for me to differentiate. So now f of x on now I'm going to differentiate this with respect to x. Always remember, first rewrite the function in a convenient way for you to differentiate. Then start differentiating. So when I differentiate the function 1 with respect to x, what do I get? F dash of x is equal to x power half on differentiation gives me half x power half minus 1 minus half into x power minus half minus 1. So this is half x power minus half minus into minus plus half x power minus 3 by 2. As I told you, always the answers to be expressed with positive powers. So I'm going to write this as 1 by 2 x power half plus 1 by 2 x power 3 by 2. And if I see the question, it has root x in it. It is expressed as surds. I'm going to rewrite this just like how it is in the question. So it's root x plus 1 by 2 root of x cube. You can leave it here and you can also write it like this, or you can write it in its simplest form like this. The surds can be expressed in its simplest form. Okay. So let's move on to the next question. F of x is given. We are supposed to find f dash of 0, f dash of 3 and f dash of 8. So with the given f of x, first let's find f dash of x. So what is f of x? It's given to be 16x plus 2. So when I differentiate this with respect to x, my f of x gives me f dash of x, and on the right hand side 16x on differentiation. I've already told you, I'm again repeating, when 6 on differentiation gives me 1. X on differentiation gives me 1. Whenever I differentiate x with respect to x, I get 1. So 16x on differentiation, 16 is the numerical coefficient, keep it like that, x on differentiation give me 1, and then plus 2. This is a constant term, or that on differentiation gives me 0. So the answer is 16. So my f dash of x is 16. Now, what am I supposed to find? I'm supposed to find f dash of 0. So wherever x is, I need to replace it with the 0 on the right hand side. Am I having any x here? I don't have. So this 0, I don't have an opportunity anywhere to replace. So my 16 remains 16 itself, because it's a constant function. Now my f dash of 3 again is going to be 16. My f dash of 8 is also going to be 16. because my derivative does not have x in it. So it's going to remain the same for any value of x. Okay, so we'll move on. Now v is given to be 4 by 3 pi r cube. We're supposed to find dv by dr. That's nothing but rate of change of v with respect to r. Hence, dv by dr when r is equal to 2 should also be found out. Okay. So I have v is equal to 4 by 3 pi r cube. Now let me see how to differentiate this. So let me differentiate this with respect to, always it is differentiated with respect to the independent variable. dr is what I am asked to find out. So differentiating with respect to r, v on differentiation with respect to r gives me dv by dr. This is equal to. Now let's observe this. It's 4 by 3 pi. Is pi a constant or a variable? Pi is an irrational number. It's a constant. It has the fixed value. It's 3.14 rounded off into the decimal form, and the approximate fractional value is 22 by 7. So it is a constant number. So 4 by 3 pi is a constant coefficient here. So any variable term with a constant coefficient, the constant is kept as it is and we differentiate only r cube. So when I differentiate r cube with respect to r, what do I get? It's like how we treat x. So we bring the power down, 3, r power 3 minus 1. So I have 4 by 3 pi 3 r square. Now when I simplify this, I know that I can cancel this out. So my dv by dr is going to be 4 pi r square. Now what am I asked to find? I am asked to find dv by dr at r is equal to 2. So dv by dr when my r is 2 is nothing but, replace r by 2 here, it's 4 into pi into 2 square. So that is 4 pi into 4, that is equal to 16 pi. So it's just simple differentiation. In case you are asked to find the derivative at a particular point, replace the value for the variable and find the answer. That's all with this video. Thank you. Saira.